Welcome to Arcane Craft YouTube channel. Let's see how to make a simple and powerful plasma lighter like this in this video. At first, take a piece of thick wire and connect one of its ends to a long, thin wire. Then wind the thin wire around the spool of an old transformer. After every 100 turns, wrap a layer of cello tape over the winding. Keep doing this until you reach 500 turns. This will be the secondary winding of the transformer. Here I am using cello tape as insulation to prevent voltage leakage between the windings. But it's better to use insulation varnish instead of cello tape because it fills air gaps and prevents voltage leakage. After completing 500 turns, cut the wire like this. After that, wrap it with insulation tape to prevent the wire from unwinding and to avoid voltage leakage. Take a ferrite core from a discarded electronic transformer, wind a thicker wire around it 10 times. Pull out a connection from the center of the winding. This winding will split into the primary and feedback windings. Remove the insulation from the ends of the leads using a lamp flame. Connect a 1000 ohm resistor between one end of the winding and gate terminal of an IFS 44N MOSFET. This wire sends negative feedback to the MOSFET gate, causing it to switch on and off at resonant frequency. At the resonant frequency, the magnetic flux oscillates with maximum amplitude, producing a high induced voltage even with fewer turns in the winding. Connect the other end of the winding to the drain, middle terminal, of the MOSFET. Place the spool onto the ferrite core and connect its ends to a piece of ferrite core. Secure the transformer and MOSFET together using a rubber band. Connect a wire to the source pin of the MOSFET. This wire will go to the negative terminal of the battery. Use a thick wire to connect the secondary winding to prevent voltage leakage, as it carries high voltage. Use heat shrink tubing to prevent high voltage from leak out. Let's test the transformer using a 3.7V battery. Connect the common connection of primary and feedback with positive and source terminal to negative of the battery. This is about 20 kV 40 kV voltage. Provide a casing to cover the entire setup, and bring out the output for sparking as well as the connections for a push button. Connect a push button between positive of the battery and the common of feedback and primary. Press the push button to see it working.